Hi everybody. Okay, this video serves as revision for complex numbers, okay, which is the first chapter you learn in Math Specialist, alright? So let's start with something easy. Let's start with the preliminary knowledge. Okay, let's start with how many forms we have in complex numbers. You should know by now that we have got Cartesian form, which is sec equals to x plus yi. We have got polar form, which is sec equals to r cos theta. We have got one more exponential form, which is sec equals to r exponent I theta. Let's start with Cartesian form. Cartesian form is represented by x and y, okay, and the real part of sec is simply x and the imaginary part of sec is simply y. So how do you tell whether it is real or imaginary? You will have to then see where is your I. Okay, so I over here is what we call the square root of -1, or we call it the surd of -1. Okay, so let's look at this example. If I were to give you sec equals to 3 plus 2i, you can simply tell me real part of sec is equals to 3 and imaginary part of sec is equals to 2. Okay, and what then about polar form? Cis simply stands for cos plus I sine, and note that it must always be plus in between cos and sine, right? So it is just cos plus I sine. So if you were to compare your Cartesian form with your polar form, x it's equivalent to r cos theta. Can you tell from here? Okay, x is equals to r cos theta, and your y is simply r sine theta. Okay, you need to note this because later on we are going to discuss on how you can convert between forms, alright? And one last one would be the exponential form, where it is z equals to r exponent I theta. So how is this exponent form formed? You got to just convert whatever that is given to you into polar form, and whatever cis that you got will simply be the exponent I. Okay, so what is next? Okay, let's look at the conjugate of sec, which is written as sec bar or sec star. So for Cartesian form, okay, what would the conjugate of sec be? It will simply be sec bar equals to x plus yi. So to put it simply, you're supposed to change the sign of the imaginary part. What then for polar form? Sec bar or sec star, it's equivalent to r cis negative theta. Hence, you are changing the sign of your argument. And what about for your exponential form? Your sec bar is simply r exponent negative I theta, and again you are changing the sign of your argument. Okay, so what then is modulus and argument? Alright, you have learned this. Modulus is also called the norm or the absolute value of sec. Okay, it's simply written like this. Okay, the modulus of sec. So what is the modulus of sec? If you were to look at the polar form and the exponential form, it is just r. What then for Cartesian form? You will then need to do a little bit more work, where you will need to have your r to be written as the square root of x squared plus y squared. Right? So as simple as that. That is the modulus. And this modulus is to tell the distance from the origin. Okay? The distance of a point z from the origin. What then for argument of z? Argument of z is denoted as arg in bracket sec, and it is simply the angle from the positive x-axis, hence it is theta. So how is, theta from polar form and exponential form you can easily find, but what then for Cartesian form? You need to do a little bit more work, where theta is to be calculated by using the formula tangent inverse y equals to x. But bear in mind to check quadrant when you're using this formula. Okay, and what next? Okay, as promised, we are going to talk about the conversion between forms. Yeah. So how do we convert Cartesian form into polar, and then from polar to exponential form? Easily, your x is simply equivalent to, just like what we have noted earlier, your x is simply equivalent to r cos theta, and your y is simply r sine theta. Okay, so if you know your r and your theta, you shouldn't have problem converting from polar to Cartesian. Okay, what then if you were to do it the other way around? Easy, just like what I told you earlier. Modulus is simply r, which is the modulus of sec, okay? And it is simply square root of x squared plus y squared. So if you could have your x and y given to you, you got to just go with r equals to square root x squared plus y squared. That is how you get your modulus. And you got to just go with the formula tangent inverse y equals to x. That is when you will get your angle. But then again, note to check the quadrant. Alright, so that is for preliminary knowledge. Okay, later on you're going to see more videos where I'm going to talk about the more detailed things of complex numbers.